All right, this is a one-way ANOVA test. This is our last section, 12.2, and we're going to show you how to do this with StatCrunch and then kind of talk a little bit about one-way ANOVA in general. Before, we've been fine with analyzing just two samples compared to each other. This is going to allow us to compare 3, 4, 5, or whatever. So our null hypothesis is for these are like three types of cigarettes and the nicotine content in each one. So our null is that they would all have the same average. So pretty much your null hypothesis is always going to be like mu1 equals mu2 equals mu3. If there's a fourth one, it's mu4. So the null is always going to be equal. The alternative hypothesis is that at least one of the populations has a different mean. Okay, so I'll go ahead and check that. Now, they want us to calculate the F statistic. So we're going to do this on StatCrunch. So I'm going to go ahead and click the data. And here's the data table. It shows each brand and the nicotine content. So I'm going to open these in StatCrunch. And we're going to tell StatCrunch to do a one-way ANOVA test. So we go under Stat, and then we go down to ANOVA, one-way. There we see that? Stat, ANOVA, one-way. And then I just have to highlight the three categories here. So I'm going to compare king size to 100 is it millimeter to menthol and non-menthol. See if there's a difference in the nicotine content. So our null is that it doesn't matter. Our alternative is that at least one is different. And we just hit compute, and it gives us the printout. And it gives us the mean and standard deviation for all three. It calculates the F statistic for us and the p-value. So our p-value here is 0.0422. So the probability that we would see this much difference in nicotine content just by random chance is about a 4% chance. So the question is that a significant difference? Is there at least one of these that has a significant different than the others? It looks like this one's got 0.89 to 1.15. Looks like there could be a difference there. So we're really analyzing if there's at least one that is significantly different than the others. And based on this printout, we'll go back here. So the F stat is what? 3.567. Here we go. So 3.567. Oh, I said 4 decimal places. So that was what? 3.5672. I'll put that in there too, and I can get rid of that. Check. All right. And then the p-value, which gave us was what again? 0.0422. 0.0422. And since our alpha level is 0.05, p-value is less than 0.05, which means we will reject the null. There is sufficient evidence to warrant the rejection of the claim that they're all the same. There we go. Do the filters appear to make a difference? So if we go back to that data table, or let's go back to our printout. If we go back, it says, do filters make a difference? So the filtered ones are significantly, it looks like there's a significantly lower. So we could say, yeah, there probably is compared to the king size anyway. So let's take a look at this. The results are inconclusive because the king size cigarettes are different size. No, the filters don't appear to make a difference because there is sufficient evidence to warrant. That would obviously be not it. Given the king size cigarettes have the largest mean, it appears the filters do make a difference. No, the filters do not make a difference. There's insufficient evidence. So, well, obviously we found there was statistically significant evidence, but the question is this question answered by what we analyzed? We're just saying, is there at least one that's different? Or are we looking at two specific ones? So I'm going to just try C here. And it's saying, yeah, because the king size cigarettes are bigger, so we would have more nicotine. There's more tobacco. Okay? That all we're answering is there one that's at least different? If we want to do further analysis between each one, we could do that. But that's not really what we're just kind of saying, is this worth looking at or not at this point? So that's pretty much it. So hope this little video helps. And so remember, use StatCrunch to calculate on your test. What I would do is probably give you something very similar to the printout here. I would give you a situation like this, and I'd say, okay, what's the null and alternative? The null hypothesis, mu1 equals mu2 equals mu3. What's the alternative? At least one is different. I would give you the F stat and p-value, and then I'd say, what would you decide? You would say, I would reject. It looks like there's at least one that's different. Or if it's a different scenario where the p-value is large, you'd say, do not reject. So that's how I could ask this on a test, and this kind of culminates what we've been studying and relying on technology to do the kind of the work, but us to kind of know what is the known alternative and what decisions do we make based on that.